What is this? This is what's known as the Hubble Deep Field North. What you're looking at is you are looking at the deepest part of the universe. So all of those little all of those little lights there that are blue, orange, white, yellow, those are all galaxies. Now there are a couple of exceptions. There are a couple of stars that kind of got mixed in there that are close by, but for the most part, every single thing, every single little dot that's in there is a galaxy. And this is looking the furthest away from furthest away that we have ever been able to see, which is why it's considered one of the most important pictures in astronomy. All right, so today what we're going to do is we're going to go over galaxies, the different types of galaxies, how they formed, and how, more importantly, how astronomers know what they know about galaxies. And then we're going to go into I'll give an explanation of how to do the next lab, and then later on today I will put the questions for today's lesson on Microsoft Forms, and I'll do the same thing for the lab with an explanation, basically a recap of how to do the lab. All right, so starting out with today's lesson. So explain what this is. So let's move on, and we're going to say that most stars are found in galaxies. Okay, and then most galaxies are going to have between 100 million to 500 billion stars, depending on their size. So a small galaxy would only have 100 million, and a large galaxy would have 500 billion stars. There are some lone stars that are between galaxies, but they're rare, and they are intergalactic stars that are drifting between galaxies. And they just kind of got lost, either thrown out of a galaxy or lost or something like that. Galaxies come in many different shapes and sizes. Let's go back here. So you see here, this is these are different pictures of different spiral galaxies. Spiral galaxies are a very common type of galaxy that is in the universe. A spiral galaxy, they're usually rotating. They have two or more spirals that are kind of coming out from the center, and the stars appear to be rotating around some type of a galactic center. And remember last week what we learned is that there is, in our own galaxy, the Milky Way, there is a supermassive black hole that is there. So they assume that that's the case for most galaxies, because most galaxies, astronomers have observed evidence of a supermassive black hole. Another type of galaxy, very common galaxy, is called an elliptical galaxy. Elliptical galaxies, they look like ellipse. They can look spherical, they can look elliptical, but they don't have that structural shape that a spiral galaxy has. Irregular galaxies, they're the type of galaxies that don't really fit into a spiral or a spherical category, and they just kind of have like an irregular, odd shape. And we'll talk about probably what causes irregular galaxies in a little bit. So the three main types of galaxies we have are spiral, elliptical, and irregular. And the way astronomers categorize them, so they give spirals an S category, elliptical an E, and an irregular an IRR. Most spiral galaxies have some type of a bar in the middle. And at the edges of those bars, you have the stream of stars that kind of come off of the edges of those bars. You have the categories of spiral galaxies. They can be S0, which is a thin disk that doesn't have it's hard to distinguish the spiral arms, or you could have an SD, which has very loose arms, and you can tell very easily what those arms are. So you've got S, A, B, C, and D, and then A, B, C, and D are just a category sequence. In like, you know, they could have just as easily have put 1, 2, 3, 4, but for whatever reason they decided to use A, B, C, and D. The elliptical galaxies, they do have numbers, and the numbers indicate the eccentricity of the galaxy. So for an E0 that has an eccentricity of 0, meaning that it is not elongated and it is considered very spherical. However, you can have as much as an E7, which is going to be a very elongated galaxy, and it looks very egg-shaped, and anything in between. So as you can see in these illustrations, these are different galaxies and the categories that they have been given for elliptical galaxies. So elliptical galaxies are going to have mainly population 2 stars, and spiral galaxies will have mostly population 2 and 1 stars. Now, recap of population 1. Population 1 stars are going to be new stars. Population 2 are going to be older stars. So what this tells astronomers is that elliptical galaxies are going to be typically older type galaxies, whereas spiral galaxies, this is evidence that spiral galaxies are younger, and eventually, I think we'll get into this, but I think the main outcome for most galaxies is going to be an elliptical galaxy. So they might start out as a spiral galaxy, and then through evolution, interactions with other galaxies, they end up as elliptical galaxies, which we'll see later on in the presentation. So here's an irregular galaxy again. And so going back to population 1, 2, and 3 type of stars, which is what the astronomers are looking for in these galaxies, that tells them how old the galaxy is and what they can expect. Population 1 star is going to be younger, and they're going to have a high metallicity, meaning that they were developed from star remnants of supernova and nova. So these are like second and third, and maybe even fourth generation stars. Population 2 stars, they're going to be a second generation star, meaning that they came from a population 1 star and some type of nova explosion, and so it's got some metals in them. And then you got population 3 stars, which are going to be the very old, the first type of stars that were ever formed. They have very low metallosity because they only are comprised of hydrogen, mostly hydrogen, and then they have some helium. And to get the heavier elements, you have to undergo a supernova explosion. And so therefore, that's one way by looking at the types of stars that the galaxies have, that astronomers can deduce how old they are and what they're mostly comprised of. So the population 3 stars, like I said, they were the first stars to exist because they come from just hydrogen. And then from the population 1 stars, which are the newest stars, they're going to be coming from gas and dust and nebulas within the galaxy and galaxies, and they can only exist after the death of older stars. So they can only form, and then they have the heavier elements, which is what makes them a population 1 or 2 star. Like I said, this indicates spiral galaxies are probably younger than elliptical galaxies, and the elliptical galaxies are a little older because of based on the types of stars that you see in elliptical and spiral galaxies. So, telescopic views of other outer reaches of our galaxies. So the galaxies that we see are 13 billion years, which means that they were the galaxies that we see 13 billion years, a galaxy that we see that is 13 billion light years away, that means that we are looking at the light it generated 13 billion years ago. So that galaxy could look very, very different than what it does right now, but this is all we can see. This also allows astronomers to see the galaxy forming in the early universe. So the further that we can see into the out into the universe with bigger telescopes and more powerful telescopes, the further back in time we can see. And the ultimate goal is to actually see if astronomers can catch some light that occurred close to the Big Bang, if not the Big Bang. So then also the earlier galaxies, they're seeing that the earlier galaxies are mostly spiral galaxies, which fits a narrative that we're gonna see. And it's believed that there is a supermassive black hole at most galactic centers. So let's look at galaxy formation. So in a galaxy formation, you have population 3 stars, which are the first stars, and they were huge, massive. And because they were so massive, whenever they collapsed, most of them would have turned into black holes very quickly, and ejecting a lot of the gas and dust that was away from the point of no return. Those black holes would often merge with one another, and then they combine their masses. So you'd have these black holes, and then they would come close to each other and merge together, forming bigger black holes and bigger black holes. And because they were so massive and things would kind of orbit around them, they became the center of a lot of these galaxies. And because of their orbits, they formed the spiral arms that are familiar. And when we talk about other black holes in the center of galaxies, and galaxies are drifting, and every now and then galaxies come close to each other and they can merge and collide. So the type of galaxy that's going to be formed is going to depend on the rotational velocity of the gas at the beginning of the formation. And it also depends on the magnitude of the random motion of the gas. So that determines what type of spiral galaxy is going to form. Galaxies change their shape as a result of collisions, which is how we would typically get irregular galaxies. So no individual stars, well, it's not, I don't want to say no individual stars, but very rarely would stars ever collide with each other within a galaxy. There is so much space, empty space between each one of the galaxies, that the chances that a star would hit another star are very, very rare. And we are actually on a collision course with the Andromeda Galaxy, and the result of that is going to be Milkdromeda. But it's not going to happen for another several billion years from now, and our sun may not. I don't even know that I don't think our sun is even going to be around by then. So if humans are to see it, they're going to have to have colonized other parts of the galaxy in order to see the merger of the Milky Way and the Andromeda Galaxy. After the merger between two galaxies, usually you'll get one huge galaxy, and this is sometimes called galactic cannibalism. And as you can see in this illustration, I think I made a mess. I messed up something here. Am I still live? I think I am still live. Okay, good. All right, going back to cannibalism and galactic cannibalism. And then the merger is going to be typically some type of an elliptical galaxy. So galaxies usually start out as spiral galaxies. Their collisions are going to make some type of irregular galaxy, and then after the collision settles out, you're going to have an elliptical galaxy. And this has been this has kind of been observed time and time again, and also they have computer simulations that have shown this time and time again. So it's observed in the natural world, in the universe, and it's also been demonstrated in not observed like the galaxies explode, because that takes billions of years. What we saw in that illustration, this illustration, let me go back for a second. This illustration that we're talking about right here is taking billions and billions and billions and billions of years to occur.
Motion detected at the front door.
Galaxies tend to be found near each other in clusters, and there is, so you know, it could, you have a large, very large galaxy typically in the middle, and it's going to be usually an elliptical galaxy. And so, you know, the same thing that kind of makes our solar system and, you know, the solar systems and galaxies, the same driving force, which is gravity, is also going to form kind of clusters and formations of galaxies in another level. So it's just another level of systems. So the further away astronomers look, the further back in time they can see. So these are, and this is kind of what is, you know, how astronomers have categorized. You see 11 billion years ago, 4 billion years ago, today. This is what they, you know, close to where we're at, and this allows astronomers to kind of see an evolution or a changing of the galaxies and what type of galaxies are going to be common at certain phases of the universe's existence. So far away, the further away you're looking at very new clusters, and they are a higher proportion of spiral galaxies. Nearby, so galaxies that are a little bit closer, that are older and closer to our, what we can see closer to our timeline, are going to be more elliptical galaxies. So that kind of shows a trend, and so that's the conclusion of today's